Today I'm going to be talking about fluid dynamics. It's a concept in physics when we talk about the dynamics and the movement and the behavior of water, or actually different types of fluid. Doesn't have to be water. So I just mentioned water because today I'm going to be demoing the behavior of water when it's in a fluid state. Hydrostatics is going to work as a concept, and if you look at it from the side, if you're on level with the water and you can kind of have a cutaway section of the water, then you can almost think of fluid dynamics, and especially the balance of buoyancy and the balance of how objects can either float or sink in water. You can look at it like a X and Y axis almost, if you look at it from the side. So the farther you go down on the y-axis, in math this would be in the negative numbers. This means that an object would have to be denser than whatever fluid that it's in. So if I drop a rock, which is much denser than water, it's going to sink, right? So the whole point of designing any type of watercraft or creating buoyancy is whenever we add more volume and we have less dense of an object. So it's going to be a balance between density and volume. That's why you see pontoons that are going to be hollow. That's also why you see inflated boats that usually run rapids, like this Class 2 rapid on the Ocoee River named Double Trouble. So that's what happens when we have hydrostatics, when we have water that's being well behaved, nice, and it's just sitting very still. Next we have hydraulic motion, or fluid dynamics. This is what happens when we set water into motion, and we try to predict what it does. So as gravity pulls down to areas of lower elevation, it's going to flow over rocks. Depending on the volume of water, the amount of water that's flowing, we can have different things called hydraulics, which are these holes that you see people falling off of their rafts in. So we got a floater, right? And they didn't lose anyone either, so that's good. Good for them. Hydraulics that we have so much fun going over with boats are created as large volumes of water flows over rocks, right? There's two different types of current. There's the whitewater that you see on the top surface, and then there's the undercurrent, which often is flowing much faster, and it's also much more dangerous because it's close to the rocks. So in the case of swimmers, right, if we don't have the, if we're not lucky enough to have a nice boat that's very buoyant and on top of the water, how are we going to survive a rapid and stay away from the undercurrent if we're just trying to swim it by our lonesome? First, we have to create buoyancy by wearing a safety certified PFD, personal flotation device. That's why they're not going to let anyone go down the river without one. Also wear a helmet for safety as well. So that's one way to create buoyancy. That's why we naturally hold our breath as an instinct in water. So as you guys see with my very complex, very artistic illustration here, is if we have an object that is less dense, represented by the dots, it's going to naturally float to the surface. So that'd be like air in lungs. If you exhale all the air in your lungs, you'll sink, and then if you inhale and put air in your lungs, then you'll float up to the top. Alright, so now onto the business of swimming this rapid and making it to the end. We need to practice very careful weight distribution, which means that we need to make sure that, that's my better chart, we need to make sure that our body is at the top, right, at the whitewater surface of the rapid. That means by spreading as much of our body across the surface of the water as possible, creating an even weight distribution and staying in the safer part of the rapid. Weight distribution is also going to be very important whenever we create buoyancy for hydrostatics too, because the more weight that you distribute across the top plane of the water, then the more volume you're going to displace from that fluid, and the better you're going to float. Alright. So what we do not want to do is go down perpendicular to this rapid, right? Because we're going to be in the undercurrent, which could suck us under, and we're also going to be close to the rocks, which can trap an ankle, trap a foot, break an ankle or just flat pin us against a rock down at the bottom surface of the river, and we definitely do not want that. So that is a big no-no. That is a big yes. All right, enough talking. Let's do the thing.